Well, this is certainly a challenging problem. We are asked to find the value of x that will make the left and the right hand side equal to each other. One thing we can do is we can kind of do an initial look at Desmos and see if we can, kind of approximate where the solution is. Maybe we can find it exactly with Desmos. And then we'll talk about the mechanics of what the algebraic thinking looks like that would get the solution. So let's do this backward. Let's start with a solution. Let's jump to Desmos. So in here I'm going to type a numerator of 2x, and I'm going to divide that by a denominator of x minus 3. Okay. And that is going to equal, in the numerator I have a 2x plus a 1, and I'm going to divide that by x plus 2. Ugh. Okay, so I do not, as I zoom around here, oh, looks like I have something here. And can it give me the value? It's not giving me the value. But it appears that it's somewhere, less than 0, right? And it's a negative number, but it's greater than -1, maybe a quarter or something. One other option I have is I can graph the left and right hand side independently. So if I copy this, I can graph the left hand side. Ooh, that's a funky curve. And then I can grab this, whoops, copy, and I can graph the right hand side. Look at that. So it looks to me like my solution is x is -1/3. And when x is -1/3, it looks like it makes both the left and the right hand side equal to 2/10 or 1/5. So let's see if we can get that algebraically. So let's go back to our ink. So one of the things that we've discussed many times is this idea of fraction busters, right? I can eliminate fractions by multiplying both the left and right hand side by something, right? I can do that. And certainly that applies here. If I wanted to, on the left hand side and the right hand side, I could decide to multiply both sides by x plus 2. So I'm going to do that on both sides times x plus 2. Okay, now when I do that, I got to be real careful here. There is a common factor. There's a common factor of x plus 2 in both the numerator and denominator over on the right hand side. And when I combine those, right, these make a giant 1, right? X plus 2, that quantity divided by x plus 2 is 1. And that leaves my right hand side rather quite nice. It just becomes an x plus, or 2x plus 1. So over on the other side, I do have to distribute. I do have to distribute this x plus 2 times the 2x, because it's not going to cancel with that denominator. So when I do that, it's going to become, let's see, I have to multiply the 2x by both the x and the 2. So if I distribute that 2x, it's going to become 2x squared, and then plus 4x. So I'm just multiplying this x plus 2 times the 2x, right? I'm multiplying both sides by x plus 2. When I do it on this side, nothing canceled with the denominator. So I still have that this is all over x minus 3. So what I'm going to do next is I'm going to multiply both sides of this equation by x minus 3. So if I multiply this side by x minus 3, right, and I have to make sure it's this quantity. I'm multiplying the entire side by x minus 3. And then over here, I'm going to be multiplying by x minus 3. What's beautiful this time is you can see that this x minus 3 is exactly the expression I have in my denominator. So that is a common factor of both the numerator and denominator. So I make this giant 1, and those are gone. And what I'm left with now is in my numerator I have 2x squared plus 4x. And on the other side I have this expression that I get when I multiply 2x plus 1 times x minus 3. Well, that is a binomial times a binomial. And we could probably do that without a generic area model, but I'm going to choose to look at one. So as a generic area model, I'm going to write, let's see, I'll go 2x and then a positive 1, and and then an x, and a negative 3. So if I want to find the product of these, right, what I do is I have to find the area of each little individual rectangle, and to get the area of rectangles, you multiply the dimensions. So I'm going to multiply this 2x times x, and when I multiply 2x times x, I get 2x to the second power. And then above that, I'm going to multiply 1 times x, which gives me x. In the upper right-hand box, 1 times negative 3 is negative 3. And then down below that, I have a 2x times negative 3, which is negative 6. Here you go, negative 6 times x. So now that I know what the area of each individual piece is, I do know that 2 of these areas can be combined because they are like terms. So I'm going to add these areas together to get the value of this product. The first time, there we go. When I have the 2x squared, and then I can combine the x and the negative 6x, which gives me minus 5x, and then I have this negative 3. So I know exactly what that product is, and now I can write that into the expression, right? So when I multiply these, right, the binomial times this other binomial, this is the product that I get. So I can write down that is 2x squared minus 5x and then minus 3. Okay, so we can move on and solve this. The first thing I notice is both sides do have a 2x squared, right? I'm grateful for that. Because now I don't have to deal with the quadratic. The equation is going to become 4 times x equals negative 5x minus 3. Therefore, if I add 5x to each side, we have 9x is negative 3, and x is negative 3/9, which is negative 1/3. And that's exactly what we saw, right, when we looked at Desmos. That's exactly what we saw that x was going to be. Where is Desmos? Here's Desmos, right? We saw that it was going to have to be that value. So yeah, we found it. We found the value of x that makes both sides the same. In fact, it makes both sides equal to 1/5 or 0.2, 2/10. One other thing before we move on. I am always reluctant to talk about this because I've seen errors be made. But I do want to point out that there is a slight shortcut that might be useful here. If I look at the original problem, let me grab that, and I think I can copy it, and I can come over here and I can paste it. So when I look at this expression, right, what I see big pictures is I see a fraction is equal to another fraction, right? There's no other terms being added here, right? It's just simply a fraction equals a fraction. And whenever we have that, this is what we call a proportion, right? We have one ratio equals another ratio. And anytime that we have a ratio equals a ratio, there's a shortcut we can use, and the shortcut comes from Fraction Busters, right? If I multiply both sides of this by BD, right? Multiply both sides by BD. Over on the right-hand side, I can see the factors of this D and D are gone, and over here, there's a common factor of B and B. And what this becomes is it becomes A times D equals C times B, right? I'm just looking. There's an A times D left over here and a C times B left over here. Well, here's the shortcut, right? If I look at the original problem, the way that it was written, one of the things I can do is because this is a proportion, I can say, oh, these cross products, and I don't even like using that phrase because so much bad overgeneralization happens, but the product of A times D will equal the product of B times C. And I can see that that's true, right? I can see that that's exactly true, right? You can see I end up with CB. There's the CB right there. And I end up with, oh, I should use the green pen. and I have AD, and you can see there's the product of AD right there. So if you have a proportion, then this is true, right? The cross products are equal. So because of that, I can say, look, I can multiply this x plus 2 times 2x, and that'll give me one side. So I can just write, hey, this is 2x times x plus 2, and that will equal this x minus 3 times this 2x plus 1, this x minus 3 times 2x plus 1. From that point on, I do exactly the same thing, right? I'm going to use the distributive property, and the simplest form of it, right here, and then also multiply this binomial times binomial, and I end up with the same problem. So yes, this is something that you see. I think I've seen some teachers draw pictures of butterflies indicating this, but it's fraught with some danger, because this only is a thing because of fraction busters, right? Because I can multiply both equal things by equal things. And because it is just a proportion equaling a ratio equaling a ratio. All right, that's it for this. Thanks for hanging in there. I'll talk to you later.